Insights.
This is Akashvani. In the program Insights, now we bring you a discussion on government's roadmap for a self-reliant and globally competitive nuclear energy ecosystem. The participants are Rahul Mahajan, senior journalist, and Diksha Saxena, Akashvani correspondent.
India is preparing for a major expansion of nuclear energy as it moves towards its goal of Viksit Bharat 2047. With that target in mind, a target of 100 gigawatts of nuclear capacity by 2047 is the focus, and not only on large reactors but also on the small modular reactors. Indigenous technology, private sector participation, and the long-term utilization of thorium. In today's Insights, we are joined by senior journalist Mr. Rahul Mahajan to take a look on India's nuclear roadmap, the role of SMRs, and the opportunities created by the SHANTI Act, and how the nuclear energy can strengthen India's energy security and technological self-reliance. Mr. Mahajan, welcome to Akashvani News.
Thank you.
So, Mr. Mahajan, before we proceed any further, my first question to you is, since India has set a target of 100 gigawatts of nuclear power capacity by 2047, how are we going to proceed and achieve this target?
So to understand this, we need to understand what is happening right now and what is the installed capacity India has right now in terms of, say, not only nuclear energy, but also solar energy, wind energy, and coal. So total India's installed power generation capacity is approximately 549.9 gigawatts, in which non-fossil sources are counting approximately 54.18% and fossil fuel sources about 45.82%. So when we talk about fossil fuel sources, we are looking at the emission which India wants to reduce, and they want to achieve net zero emission by 2070. India's installed solar power capacity. You know that India is fast achieving large solar power generation capacity. So it's right now at 162.2 gigawatt, and wind power capacity is approximately 57.4 gigawatt. Here comes the problem. The problem is the installed coal-based power capacity is approximately 224.2 gigawatt, making coal still the country's largest individual source of installed generation. The coal-based capacity shows that the nuclear power cannot immediately replace coal, and India will need to operate with a diversified mix of coal, nuclear, solar, wind, hydro power, and energy storage for several decades. And that is precisely where the expanding of nuclear power will help India reduce long-term dependence on coal, and also will support its commitment, which they have done to achieve net zero emission by 2070. And looking at this, Government of India's long-term objective is to expand India's nuclear power capacity from, as you have already listeners, that they want to expand the capacity from 8.8 gigawatt, which is right now in place, to 100 gigawatt by 2047, making nuclear energy a major pillar of India's energy security. This also means that India would need to add more than 90 gigawatt of nuclear capacity. Most important point is 100 gigawatt nuclear target should not be viewed merely as power generation program. It is also long-term strategy to build India's capacity in nuclear technology, manufacturing, private investment, and energy security. So you ask me how we are going to achieve it. India has a roadmap which is basically three-stage nuclear program with the long-term objective of making greater use of the country's thorium resources and reducing dependence on imported energy technologies. The government has also planned to pursue a dual strategy rather than relying on one reactor technology. The indigenous 700 megawatt pressurized heavy water reactors will form an important part of the planned expansion at the nuclear site. And small modular reactors are being considered for retiring fossil fuel sites. Captive industrial power generation, and basically the small modular reactors, they will cater to captive industrial power generation of grid applications in remote areas. So government wants to build a complete domestic nuclear ecosystem covering reactor technology, manufacturing, engineering, research, skill and supply chain, rather than merely increasing installed capacity. Ultimately, the success of the program should not be judged only by how many gigawatt of nuclear capacity India installs, but by whether India succeeds in developing a safe, cost-effective, timely, and scalable indigenous model of building nuclear power plants or not.
Yes, Mr. Mahajan, very rightly said. Since you mentioned a lot of points, I would also like to understand from you that what kind of role does nuclear energy play in meeting India's growing electricity needs? And as you already mentioned and spoke about the energy security, because of the current crisis globally, we have seen that it's very important to be secure at the end of energy because we cannot rely on other countries. So, how important and what role is nuclear energy playing in meeting India's growing electricity needs and ensuring India's energy security?
It's a great role. Actually, if you look at the expansion of various sectors in India, especially the chip maker or other sectors in which energy is required in a big way, we need to shift from coal-based energy to more cleaner ways of generating energy. And also, we have to cater to the growing capacity, growing requirement of energy for our expanding sector. So this is why India has thought about how to have clean energy, and the best way to have it is, other than solar and other things, it is the nuclear energy, which is the most clean way of having energy and a sustained way of having energy. And that is why government has provided something around 20,000 crore for nuclear energy mission with a major focus on developing indigenous technology.
Since you spoke about the small modular reactors or the SMRs, I would also like to understand from you what exactly does the small modular reactor mean and how are they different from the large reactors that are already existing in India?
So a small modular reactor or SMR is a modern nuclear fission plant that produces up to 300 megawatt of electricity per module, unlike huge custom-based power plants which are installed. The SMR parts are made in factories, shipped on trucks and put together on site. They use natural cooling system and need less space. So SMR use passive cooling, gravity and natural air or water flow without needing outside power. Large plants rely heavily on active electric pumps and to operate and to sustain their operation. The differences between size and power, building method, safety systems, these are the differences. SMR generate around 300 megawatt above, and the large reactors produce around 1,000 megawatt. So there is a size and power generation difference. The building methods are also different. Large reactors are custom built entirely on the site over many years, but SMRs can be built piece by piece in factories and they can be assembled later on the site. And I have already explained the cooling method is also different. So large plants, they heavily rely on electric pumps and operator control. But smaller SMRs they are easier to handle, easier to.
The SHANTI Act, which allows a greater participation of the private sector in the nuclear sector. How are private companies helping in India's expansion in the nuclear power? We have seen a lot of private sector participation in the other sectors as well. So when we talk about the nuclear energy sector, which is really important for India, what kind of role is the private sector playing in the nuclear energy sector?
So SHANTI Act is an enabling law which will allow private sector to contribute to the energy needs of India and operate in this sector of nuclear energy. To understand this, we have to understand the SHANTI Act, what exactly it is. The full form of SHANTI Act is Sustainable Harnessing and Advancement of Nuclear Energy for Transforming India. It's basically creates a new legal framework for India's nuclear sector, and the Act replaces and consolidates the framework earlier governed by the Atomic Energy Act 1962 and the Civil Liability for Nuclear Damage Act. One of the biggest changes is that the government can now license Indian private companies. Ask me how the Indian private sector will contribute to this. That according to this act, or which enables that the Indian private companies, their joint ventures and other permitted entities, they can build, own, operate nuclear power plants subject to prescribed conditions. The act provides for graded liability framework for nuclear operators, with financial liability ranging from 100 crore to 3,000 crore, depending on the capacity of nuclear installation. Liability beyond the prescribed limit may fall on the government. This is a significant change because earlier legal provisions allowing an operator to seek recourse against a supplier for defective equipment and materials has been removed. So this was a roadblock in foreign companies and private companies to enter this sector. So this roadblock has been removed. That is why the SHANTI Act is considered to be the game changer in the nuclear energy power.
Mr. Mahajan, also India has huge reserves of thorium, as I had mentioned in the introduction as well. So how important will thorium be for India's future of nuclear energy program?
So when we talk about this whole, you can say, program of India making nuclear energy as a pillar of our security or energy security, we have taken care that the indigenous thorium-based plants should be expanded because we cannot remain dependent on the supply of, you can say, foreign nuclear material to generate the power in power plants. So in this whole thought and in this whole system which we are building, thorium has a particular role to play.
Also, Mr. Mahajan, can the nuclear energy help India in reducing its dependence on fossil fuels while we are also eyeing to meet the goals of like the climate goals?
We already have a coal-based power capacity, which is huge, 224.2 gigawatt. So we have a commitment to reduce it. We have a commitment to achieve net zero emissions by 2070. To achieve this, of course, one of the ways to reduce it is the nuclear power. And we can generate. You understand that in case of solar power, you have to put up large plants in a larger area. And by that, you generate lesser energy in comparison to the nuclear power generation plants. So nuclear power generation plants use lesser areas and produce more energy. So it is a win-win situation for India if they can expand the nuclear power energy generation and reduce their dependence on the coal and specifically fossil fuel by which they are generating a lot of energy.
I would like to also understand from you, since we discussed India's goal for Viksit Bharat by 2047, and we also discussed the various aspects of the nuclear energy, the SHANTI Act. I would like to briefly understand from you, what are the biggest challenges that we need to overcome to achieve the target of Viksit Bharat by 2047 when we are looking at India's nuclear energy?
Biggest challenge is the execution speed. Nuclear projects involve land acquisition, environmental clearances, safety approvals, financing, construction and local acceptance, all of which can take considerable time. Reaching 100 gigawatt by 2047 will require more than simple ordering new reactors. India will need to standardize reactor designs, faster construction, domestic supply chains, skilled manpower. So private investors will need clarity if they want to do it and they enter into this sector in a large way, then the private investors will need clarity on electricity tariffs, project risk, accident liability, insurance, regulatory processes, power purchase agreements are most important before committing large amounts of capital. You understand that putting a power plant needs a lot of money and capital to do it. These are the challenges before us. And another challenge is that the solar and wind capacity is expanding rapidly, meaning India will simultaneously need major investments in electricity storage, transmission, and grid management.
Thank you so much, Mr. Mahajan, for giving us such insights on the subject and for joining us tonight for Insights.
Thank you.
You were listening to a discussion on government's roadmap for a self-reliant and globally competitive nuclear energy ecosystem. The participants were Rahul Mahajan, senior journalist, and Diksha Saxena, Akashvani correspondent. This program was produced and presented by the News Services Division of Akashvani. You can listen to it on our mobile app, News on AIR. This program is also available on our YouTube channel, News on AIR Official. You may share your feedback about this program through email at airnsdtalks@gmail.com or WhatsApp on 9289094044.
Insights.
You were listening to a discussion on government's roadmap for a self-reliant and globally competitive nuclear energy ecosystem. The participants were Rahul Mahajan, senior journalist, and Diksha Saxena, Akashvani correspondent. This program was produced and presented by the News Services Division of Akashvani. You can listen to it on our mobile app, News on AIR. This program is also available on our YouTube channel, News on AIR Official.
Insights.